بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about chain rule section 3.4. Write the composite function in the form f of g of x. So we need to write this function in this form, f of g of x. The inner function should be called u equals a function of x, and the outer function should be called y, and it should be a function of u, which is the inner function. So this is the inner function. We call it u, and then the outer function would be f of u, and we will call it y. So here, for example, the inner function is x cubed plus 2, so we call it u. And then we have square root of u. That's the outer function. Then y would be equal to square root of x cubed plus 2 or u. And now we need to find dy by dx. According to chain rule, dy by dx means you find the derivative of y, this y now, with respect to x. But u is a function of x, okay? So how to find the derivative of y with respect to x? You use the chain rule. Chain rule says dy by du times du by dx. So find the derivative of y with respect to u. This means the derivative of square root of u, which is 1 over 2 square root of u, times derivative of u with respect to x. So now here, this is u, find du by dx. It is 3x squared. And the final answer would be 3x squared over square root 2 times square root of u, but u is x cubed plus 2. So this would be the derivative of the function y using the chain rule. Here the inner function is cosine x. So I call u cosine x, and then this would be u. So y would be sine u. And dy by dx would be dy by du, so the derivative of sine u, which is cosine u, times dy by dx, which is the derivative of cosine x with respect to x. Derivative of cosine x is negative sine x. So the answer would be negative sine x times cosine u, but u is cosine x. U is cosine x, so this would be the answer, negative sine x times cosine u, or cosine x. So this is the derivative of y. The derivative here, the inner function is square root of x. The nice thing in these exercises, you understand here where is the inner function and where is the outer function, and y is e to the power u. So dy by dx would be dy by du, which is the derivative of e to the power u, which is eu, times the derivative of square root of x, which is 1 over 2 square root of x. So the answer would be e to the power u, but u is square root of x over 2 times square root of x. Here, the inner function is ex plus 1, and y would be cube root of u. And dy by dx would be dy by du. To find the derivative of cube root of u, this is u to the power 1 over 3. So the derivative is 1 over 3, u to the power 1 over 3 minus 1, or negative 2 over 3. times dy by dx, the derivative of ex plus 1, which is e to the power x. So the answer would be, I have e to the power x here, and below I have 3 times u to the power 2 over 3, and u is e to the power x plus 1. So this would be to the power 2 over 3, and that would be the answer. We can continue using the same method, or we can immediately now use do it fast. So to do it fast, you have to notice that this is a composition function. Okay, this function is the inner function, 2x cubed minus 5x squared plus 4, and the outer function is u to the power 5. So first you find the derivative of the outer function. So 5 times this function, the inner function, to the power 4. So this is the derivative of the outer function times the derivative of the inner function. 2x cubed, the derivative is 6x squared minus 10x. So that's the derivative. Here also, f prime of x would be the derivative of the square root is 1 over 2 square root of 5x plus 1, then times the derivative of 5x plus 1, which is 5. So this would be the derivative. Here I will write this as x squared minus 1 to the power negative 1 over 3 first. This is cube root. You can write it 1 to the power 1 over 3, and when you take it up, it would be negative. So f prime of x would be the derivative of the outer function, negative 1 over 3 x squared minus 1 to the power negative 1 over 3 minus 1, or negative 4 over 3, times the derivative of the inner function, which is 2x. So the final answer would be negative 2x over 3, and x squared minus 1, I bring it down with a positive power. Well, here f prime of t would be 4. This is the derivative of the outer function, 1 over 2t plus 1 to the power 3. This is the derivative of the outer function times the derivative of the inner function. Well, the derivative of 1 over x is negative 1 over x squared. So this is the derivative of this outer function again, times the derivative of 2t plus 1, which is 2. Okay, so put in your mind that d by dx of 1 over u is negative 1 over u squared times u prime. Okay, to find the derivative of 1 over u, negative 1 over u squared, we know this, but then you multiply by u prime if u is a function of x. So you can write the final answer as negative 2 times 4, negative 8, okay, over 2t plus 1 to the power 2 times 1 over 2t plus 1 to the power 3. That would be the final answer. Another function, what is the inner function here? Theta squared. So f prime of theta is derivative of the outer function, derivative of cosine. Derivative of cosine is negative sine, and then we multiply by derivative of theta squared, which is 2 theta. So I can write the answer negative 2 theta times sine theta squared. Here notice that this is cosine to the power 2. So it's cosine theta raised to the power 2. So g prime of theta would be 2 cosine theta to the power 1. This is the derivative of the outer function, which is parenthesis to the power 2. And then times the derivative of cosine, which is negative sine theta. So you can write it at the end as negative 2 cosine theta sine theta. Well, the derivative here is the derivative of the outer function, which is 5 to the power square root of x times ln 5, then times the derivative of the inner function, which is the square root of x, 1 over 2 square root of x. So at the end, you can write it ln 5 over 2 square root of x times 5 to the power square root of x. You can write formulas for here we used this one. We said that the derivative dy dx of b to the power u would be b to the power u times ln b times u prime, or du by dx. Okay, if you have a problem dealing with the chain rule, you can write these formulas like this and understand how to use them. Here we have products between two functions. So I will use the product rule. Remember, the product rule is f prime times g plus f times g prime. So the derivative of x squared is 2x plus x squared times the derivative of e to the power negative 3x, which is e to the power negative 3x, times the derivative of the power, which is negative 3. So the answer would be, if you want, you can take e to the power negative 3x, a common factor, or you don't, no problem with that, 2x minus 3x squared. This would be the derivative. You can even write e to the power negative 3x in the denominator as e to the power 3x. So we used here the product rule. Here also we use the product rule. The derivative of e to the power at is e to the power at times a, the derivative of at, times sine bt plus eat as it is. The derivative of sine is cosine, and the derivative of bt is b. So the final answer would be a, e to the power at sine bt plus b, e to the power at cosine bt. This is a usual chain rule. Y prime is e to the power tan theta times the derivative of tan, which is secant square theta. This is also a usual chain rule. The derivative is 2 to the power t cube times ln 2 times the derivative of t cube, which is 3t squared. So the answer would be 3t squared times 2 to the power t to the power 2 to the power 3 times ln 2. Well, here I have a square root. So s prime of t would be 1 over 2 times the square root of 1 plus sine t over 1 plus cosine t. Then times the derivative of what is inside the square root, the inner function. And here I use the quotient rule. Remember the derivative of the quotient rule, g square here, f prime g minus f g prime. So 1 plus cosine t to the power 2. And the derivative of 1 plus sine t is cosine t times 1 plus cosine t minus The derivative of cosine t is negative sine, so it would be positive. Sine t times 1 plus sine t. If we simplify what is in the numerator, we will have cosine t plus cosine square t plus sine t plus sine square t. And cosine square plus sine square is 1. So I can write it. 1 times this would be cosine, I have cosine t plus sine t plus cosine square plus sine square is 1 over 1 plus cosine t to the power 2, and there is a 2 here, okay, and 1 over this square root. I can write it if I like, square root of 1 plus cosine t over 1 plus sine t. So I write the reciprocal of what is inside the square root. All right. The derivative here is 10 to the power 2 times square root of t times ln 10 times the derivative of 2 square root of t. Derivative of square root of t is 1 over 2 square root of t. So the answer would be ln 10 over square root of t times 10 to the power t square root of t. This is ln 10. Here I have z over z minus 1 in the power, and this is the inner function. So f prime of z would be e to the power z over z minus 1 times the derivative of the inner function. And I use the quotient rule, z minus 1 square. Derivative of z is 1 times z minus 1 minus derivative of z minus 1 is 1 times z. So z would be cancelled with negative z, and the answer would be negative 1 times this. So negative ez over z minus 1 over z minus 1 to the power 2. Same, but I have the inner function here is product function. So the derivative is et sine 2t, because always d by du of e d by dx of e to the power u is e to the power u times u prime. That's the formula we are using. So here e to the power u times u prime. But u prime now is product. We have products, we use the product rule. So the derivative of t is 1 times sine 2t plus t times the derivative of sine 2t, which is cosine 2t, times the derivative of 2t, which is 2. So that's the answer. Here I have product sine x times cosine 1 minus x squared. So f prime of x would be the derivative of sine is cosine x times cosine 1 minus x squared plus sine x times the derivative of cosine is negative sine 1 minus x squared times the derivative of 1 minus x squared, the inner function, which is minus 2x. I can write the answer as cosine x, there is no change here, cosine 1 minus x squared, but here I have minus times minus, it would be plus, and I can take 2x outside, so 2x sine x times sine 1 minus x squared. This is the derivative. Here I have product function. The derivative of e to the power negative x is e to the power negative x times the derivative of negative x, which is negative 1, times cosine x squared plus e to the power negative x times the derivative of cosine, which is negative sine x squared, times the derivative of x squared, which is 2x, chain rule. So I can write it at the end as this one. The negative 2x, I can take it out, and I write it like this. Well, here the outer function is tan. So f prime would be the derivative of tan is secant square evaluated at square root times. Now the derivative of the inner function, derivative of the square root, is 1 over 2 times the square root times the derivative of the other inner function, the second inner function, if you like. Okay, derivative of 1 plus 2 t square, which is 2t. And you can write it at the end, 2 cancels with 2. You can write it t over square root of 1 plus t square times secant square of square root of 1 plus t square. Here, the derivative of g is 3 times 1 plus cosine square z to the power 2. This is the derivative of the outer function times the derivative of the inner function. Derivative of 1 is 0. Derivative of cosine square is 2 cosine to the power 1 of z times the derivative of cosine, which is negative sine z, because cosine square is cosine z to the power 2. Then I can write it negative 2 times 3, negative 6. And I have 1 plus cosine square z to the power 2. And then I have cosine z times sine z. Here I have sine square. Remember, sine square means sine to the power 2. Okay, so y prime would be 2 sine x square plus 1 times the derivative of sine, which is cosine x square plus 1. The derivative of cosine square plus 1, which is 2x. So this is the chain. Okay, you finish from the outer, you go to the inner, and then the other inner. So the final answer would be 2 times 2 is 4x, and then you write sine x square plus 1 times cosine x square plus 1. Y prime would be the derivative of e is e times the derivative of sine 2x, which is cosine 2x, times the derivative of 2x, which is 2. Okay, this is the derivative of the first function, plus. Here sine is the outer function. Derivative of sine is cosine. Then derivative of e to the power 2x times the derivative of 2x, which is 2. So I have 2 e sine 2x cosine 2x and plus 2 e 2x cosine e to the power 2x. This is how we write it at the end. The outer function here is sine. So the derivative of sine is cosine. So I will write cosine e to the power x over 1 plus e to the power x times the derivative of the inner function. And for that, I use the quotient rule. Derivative of the numerator is ex times the denominator minus derivative of the denominator, which is ex, times the numerator, which is ex. Notice that ex times ex will be cancelled with negative ex. So I will have ex times 1 in the numerator. So I can write it ex over 1 plus ex square times cosine ex over 1 plus ex. I can make it more clear for you. Here, if you multiply, you get ex plus e to the power 2x minus e to the power 2x, and these two cancels, and you still have e to the power x in the numerator. Well, f prime here is the derivative of the outer function, which is tan. Derivative of tan is secant square. Secant cosine t. Then times the derivative of secant, which is secant tan, times the derivative of cosine, which is negative sine t. So I'll just write sine t here, and the negative I'll put it here, okay, in the beginning. And that's the answer. Y prime here, well, I have sine of all of this. So sine is the outer function. Derivative of sine is cosine. I write the inner function as it is. And then I find the derivative of the inner function. Derivative of theta is 1 plus derivative of tan is secant square of the inner function. Notice that I keep this now, this parenthesis open. The derivative of theta is 1, okay? Now I am finding the derivative of tan. Derivative of tan is secant square times. Okay, so I multiply here without closing. If you do it like this, this is not correct. Okay, you have to keep this open. So times the derivative of theta plus cosine theta, which is 1. Derivative of theta is 1. Derivative of cosine is negative sine theta. And now you can close this parenthesis. Okay, so this would be the answer. If you want to write it in another way, uh, I don't think it's a good idea, but it's okay. Let me show you another way so you understand what's going on here. This is cosine theta plus tan theta plus cosine theta, okay, times. I will write this as 1, okay, then plus 1 minus sine theta times secant square theta plus cosine theta. I hope it's clear for you. So I have two terms. One is a term, one term alone, and this is the other term. All right. Now, this is sine all to the power 3. So the derivative would be 3 sine square at cosine x square times the derivative of sine itself. So derivative of sine is cosine at cosine x square. Now I finished from the derivative of sine. Go to inside, derivative of cosine. Derivative of cosine is negative. So this negative, I will write it here. Or let me keep it for now. Negative sine x square. And then the derivative of x square is 2x. And finally, I can take the minus and the 2 multiplied by 3. So I have negative 6 sine square of cosine x square and cosine of cosine x square times sine x square. And the x, I'll take it here. Okay, this x would be in the beginning. Find an equation of the tangent line. Well, the equation of the tangent line is y minus 1 equals y prime at 0, okay, x minus 0. This is always the equation of the tangent line. It is y minus f of a equals f prime at a times x minus a. This is the formula, if you remember, for the tangent line. So all what I need to find is y prime at 0. So y prime would be 2 to the power x times ln 2. And y prime at 0 would be 2 to the power 0, which is 1 times ln 2. So the equation would be y minus 1 equals ln 2 times x, okay? Or it would be y equals uh, ln 2 times x plus 1. Well, here the equation would be y minus 0 or y equals y prime at pi. Okay, this is a and this is f of a times x minus pi. So let me find y prime. Derivative of sine is cosine, the outer function, times the derivative of sine x, which is cosine x. So y prime at pi would be cosine sine pi times cosine pi. Well, sine pi is 0 and cosine 0 is 1. Okay, so this is 1 and cosine pi is just negative 1. So 1 times negative 1 would be negative 1. So y equals negative x minus pi or negative x plus pi. This would be the equation of the line. The equation of the tangent line, y minus 0 equals y prime at 0 times x minus 0. So y prime would be, this is a product rule. Derivative of x is 1 plus x times derivative of e to the power negative x square will be e to the power negative x square times the derivative of negative x square, which is negative 2x. All right, now let me find y prime at 0. E to the power 0 is 1 plus 0 times anything is 0. So the answer is 1. So the equation is y equals x. Here we need to find f capital prime of 5. What is f capital? This is f capital. So let me find f capital prime of x using the chain rule. It is f prime at g of x times g prime of x. Well, I need f capital prime at 5. So it would be f small prime g at 5 times g prime at 5. It would be f prime of. What is g of 5? It should be given in the question. Yeah, it is negative 2. G prime 5 should be given in the question. Yeah, it is 6. F prime negative 2 should be given in the question. It is 4. So 4 times 6 and the answer is 24. I need h prime of 1. Well, let me find h prime of x. This is a square root, so it is 1 over 2 times square root 4 plus 3 f of x times the derivative of the inner function. Derivative of 4 is 0. 3 times f prime of x. So h prime of 1 would be 3 times f prime of 1. I replace x, this x, I replace it by 1. Okay, over 2 times square root of 4 plus 3f of 1. Okay, so what is f prime of 1? It is 4 from the question over 2 times square root of 4 plus 3 times f of 1. What is f of 1? It is 7. Good. 3 times 4 is 12 over 2 times square root of 3 plus 7. 3 times 7, 21 plus 4, 25. Well, 12 over 2 is 6 and square root of 5 is 5. So the answer is 6 over 5. F capital prime. Using the chain rule, pay attention please. You start by the outer function, derivative of the outer function, evaluated at the inner function, 3f, 4f of x, all of it, okay, times the derivative of the inner function, so 3 times the derivative of f at 4f of x times, now the derivative of 4f of x, 4 times f prime of x. So this is the derivative of f capital. So now f capital at 0 would be f prime at 3f of 4 f of 0, okay, times 3f prime 4f of 0 times 4f prime of 0. Well, this is f prime of 3f of f of 0. F of 0 is 0. 4 times 0 is 0. Here, 3f prime of, this is f, okay? 4f of 0. F of 0 is 0, so 4 times 0 is again 0. F prime of 0. F prime of 0 is 2. What is f of 0? F of 0 is 0. 3 times 0 is 0, so I need f prime of 0 times 3 times f prime of 0, which is 2, and 4 times 2 is 8. Now what is f prime of 0 is 2 times 6 times 8, 48, and now 48 times 2 would be 96. That's the answer. I hope you understand now the chain rule better and you can solve exercises by yourself.